So now we're going to go back and we're going to put it all together into impedance. So impedance is the big three. In an AC circuit, we've got more than just resistance. We had resistance in our DC circuits, but now with AC we've got to worry about capacitive reactance and inductive reactance. Now all of these guys are given in ohms. If you remember, resistance was in ohms, and we're going to come up with the same thing when we come up with capacitance. All these guys are going to be expressed in ohms. So it's expressed like resistance, but it's really impeding flow, which is different from a resistor. With the resistor we don't have a phase shift. So with reactance we look at resistance, we look at capacitance, and that's the Powerpuff Girls. They're fast. They make quick changes, but they don't last very long. And we also have Droopy Dog. Droopy Dog tries to slow us down. He's resistant to change, and once current gets flowing he doesn't want to stop. So we put the fast element in here, and we put the slow element in here, and we put the resistance, and that is going to allow us to calculate impedance. So here's our impedance formula. We have one for series circuit and we have one for parallel circuit. Looking at just the series circuit right now, Z is impedance, and that is expressed in ohms. So the impedance in ohms is calculated by finding the square root of the resistance squared plus inductive reactance minus capacitive reactance squared. So we complete this formula, and that gives us the impedance for a series circuit. Parallel circuit is calculated with just a slightly different formula. Here are the formulas that it takes to come up with the impedance. We have to first know the resistance, or calculate the resistance of the circuit. Next we have to calculate the capacitive reactance and the inductive reactance. And once we know that, we wrap it all up into a formula that calculates the total impedance. So now you know the relationship. The relationship is that we take resistance, we take capacitive reactance and inductance, and we put them all in a bag, shake them up, and out comes the result, and that is what the phase shift will be in an AC circuit, and that is impedance.